we're going to look at the slope of parallel and perpendicular lines. I just want to point out to you some terminology or symbols that we use. This symbol here means parallel, and this one means perpendicular. Okay? When we're looking at slope, we have a formula we can use to figure it out. So our formula is y2 minus y1 over x2 minus x1. If you're wondering where the 2's and 1's come from, a reminder that they come from the ordered pairs that we're using. We normally would write an ordered pair as x, y. We're going to have 2 ordered pairs to find the slope from. But it's hard to know which ordered pair you're using. That's why we just give them the number of the ordered pair. So ordered pair 1 and ordered pair 2 give us x1, y1, x2, and y2. We put them into our slope formula, which is simply the difference in the y's over the difference in the x's. We can plug them in just doing it paper and pencil if we like, or I'm going to show you how to use it in your calculator later. If you're given a graph, you can also use rise and run, which means we start at a number on the left for simplicity's sake, and always get the positives and negatives right. Count how many up and how many over. Rise and run. Make those into a fraction and we have our formula. So let's try calculating one. If we wanted to find the slope of the line that passes through these 2 points, 3, 6, and 0, 3, the first thing I'm going to do is label my ordered pairs. They're x and y, but I'm going to call them x1, y1, and x2, y2, so I know what ordered pair they're coming from. Okay? I'm going to use my slope formula, and I'm going to put it into my formula here. So I'm starting with y2, which is negative 3. The subtracts comes from the formula, and then y1 is 6. In the denominator, I have x2 minus from the formula and x1. Now I can do the math on the numerator and the denominator and then put them together to a fraction. I have negative 3 minus 6, which is negative 9, over 0 minus 3 is negative 3, and simplify it to get 3. You can do this in your calculator. I know the calculators we're using this year don't have the same fraction symbols that we had last year, but I'm going to show you how you can still do it in there. Okay? All we're going to need to do is use a parenthesis in the numerator and one to hold the denominator to be able to use the fraction bar as a grouping symbol. So to put this into your calculator, you would start with the fraction symbol, the parenthesis, and then you would do negative 3 minus 6, what's in your numerator there. Now you have the whole numerator put in, then you can hit the fraction bar. Then you're going to put the denominator in a fraction also and do 0 minus 3. Close that parenthesis and hit enter. We did get 3, what we got when we calculated by hand. If you happen to get a decimal, you can still turn that into a fraction on your calculator. You do it on this math button here. You hit math 1 or enter for a fraction, and then enter for turning your answer into a fraction. So let's talk about parallel and perpendicular. If you remember the symbols we were using, parallel and perpendicular. Okay? We're going to talk about what these equations look like with the slope and the b or the y-intercept. So let's start with parallel lines. They have the same slope. M will be the same in both cases. We can see that from the equations here. If we have 2 equations that both have 3 as the slope or the m, we know they're going to be parallel. There's one more thing though that has to happen. I'm going to show this to you on the graph in a second. but the b, or the y-intercept, has to be different. In this case, it's -2. In this case, it's 6. And let's take a look at why they have to be different. Let me get the graphs up. We're talking about parallel lines. I'm going to move the slope here, and you'll see that they stay parallel to each other. They both have the same slope, but different y-intercepts. If I change the y-intercept, they're getting closer and further apart. I can change the green one also. Here's why they can't be the same. If I make both of the y-intercepts the same, they're both about to be 2. You see how they're the same exact line? So they do have to have a different y-intercept in order to be different lines. Okay? Let's look at perpendicular slopes now. A little bit different. Instead of being the same slope, we now have to have them be the negative or the opposite reciprocal. Okay, so if we started out with the slope being m, the perpendicular slope would be the reciprocal of it, which is turning the fraction upside down would become 1 over m, and then the negative means turning the positive into a negative. So it would be -1 over m. Okay. Here's a good example. We have, in our first instance, we're given 4 is our slope, and it's going to be perpendicular to something with -1/4 as the slope. Okay? We're going to see on the graph here that it does not matter what the y-intercept is, that they could both be the same. Okay? Let's look at our graphs of perpendicular lines. They're going to make a right angle. Whatever the slope is, the other slope will be the negative reciprocal of it. You can see what I'm doing down here if you like. I have mx plus b and -1 over m. That's my 2 equations I'm using. So they're going to stay the same. But because they have different slopes, it's not going to matter if the y-intercept changes. So if I make the green one have a y-intercept of 0, and the blue one also have a y-intercept of 0, they're still 2 different lines and they're still perpendicular. It does not matter that they have the same slope. So we're going to now look at a collection or a chart showing all of these things. First, we're going to draw some pictures of them, remind ourselves of the vocabulary, and then fill out our chart. So coinciding lines, we saw those when we had parallel lines with the same y-intercept. They're actually the same line. So if I have a line, and then I have the same line on top of it, I have coinciding lines. They just look like one line. Parallel lines are lines that are same slope. They run next to each other and they're never going to cross. Perpendicular lines are ones that are going to cross always at a right angle. I'm going to use my square marker on the angle to show that it's a right angle. Intersecting lines are just lines that intersect at any degrees. It doesn't have to be 90. They just have to intersect somewhere. So let's fill out our chart here, and then we'll be done with our notes. So coinciding lines, because they're the same line, they're going to have the same slope and the same y-intercept. Exactly the same line. Parallel lines will have the same slope, but we saw that the y-intercept had to be different. Okay, what we saw about perpendicular lines was that they needed that negative or opposite reciprocal as a slope, and it didn't matter if the y-intercept was the same or not. And intersecting lines need to have different slopes, and if they had the same, they would be parallel or coinciding. And it does not matter for the y-intercept.